This is midterm review number 8. This is a projectile, and it's ground to ground, so that makes it a type 2. So we have a soccer ball kicked with an initial speed of 20 meters per second at an angle of 30 degrees above the horizontal, and we want to find the delta x. So what's the range? So what we have to do to start, as usual, we're given a total initial velocity, but we know that in projectiles, the total initial velocity doesn't really help us. We have to break it up into its components. So our vector triangle, we have a v initial here of 20, and then we're going to have a v initial x and a v initial y. And the angle here is 30. So to find v initial x, the angle is touching the x and the hypotenuse, so we're going to have to use cosine. So v initial x is v initial times cosine of theta. So it's going to be 20 times the cosine of 30, which is going to be 17.32 meters per second. So that is how fast it moves in the x direction. And in the y direction, we do the same thing. V initial times the sine of the angle. Sine because it's opposite. So that's 20 times the sine of 30. So that's going to be 10 meters per second in the y direction. Alright, so now that's all the information that we actually have been given in the problem. Now the question says how far away does it travel? So we are looking for delta x. But by association, that means we're also looking for time x. Before we can get time x, though, we're going to need some other information. Now, what we do know is at the very top, the velocity in the y direction is 0. So we can use that information to our advantage. And because we know that the initial velocity is 10 meters per second, and the final, air quote final, because it's at the top of the path, is 0, we can figure out how much time it takes to reach the peak. So we're going to use v final y is equal to v initial y plus acceleration times time. So v final is 0, v initial is 10, acceleration is negative 10 for gravity, times t. So time is going to be 1 second, and that's time y. It's going to go up for 1 second. Now because of symmetry, especially for a type 2, time x is going to be double time y. That's because it's going to go up and then come back down in exactly the same way. So that means that time x is going to be 2 times our value of time y, which is 1. So it's going to take 2 seconds before this ball is going to hit the ground again. That's time x. And then the last part of the question, we're told to find the range, and that's our delta x. And for a range, there's only really one equation that we can use, because in the x direction, the velocity doesn't change for projectiles. So we are going to say delta x is equal to vx, which is velocity in the x direction, multiplied by tx, time in the x direction. Velocity in the x was 17.32. Time x, 2 seconds. And 17.32 times 2 is going to be 34.64 meters. I don't know why that is doing that. So that means that the total range achieved by our projectile is 34.64 meters. So the soccer ball is going to land 34.64 meters away, and that's all we have to find in this problem. So because this is a type 2, all type 2s are pretty straightforward to solve. You use the fact that the velocity at the peak is 0, and that you can find the initial velocity to find the time up, double it to get your time total, and then multiply it by your initial x velocity, and that will always tell you your range.